purpose of this video is to help you to understand how to rationalize the denominator, and in particular with roots higher than 2. So initially, let's just do one with a square root. So when we rewrite this problem, it's the square root of 2 over the square root of 3. And this is an irrational number. We're not allowed to leave the square root in the denominator because, well, sort of for historical reasons, it was hard to then come up with a decimal approximation that was accurate. So we have to do what's called rationalizing the denominator. And what that means is we cannot leave a radical in the bottom. Okay, so we can't have a radical in the denominator. But we are allowed to multiply any equation by the number 1. So what do we have really? If we have square root of 2 over the square root of 3, and if I cleverly pick the number 1, so in the parentheses here, this is the number 1. If I pick it to be the square root of 3 over the square root of 3, on the bottom I'm going to no longer have a radical, because this is really the square root of 3 squared, and then those two are going to cancel, and I have the square root of 6 over 3. Okay, so that's nice. Now what do we need to do to make this a little bit harder? What if I had the square root, make that a little bit smaller. What if I had the square root of 2 over, let's do third root of 2 over the third root of 3. Well, then the number that I need to pick for my 1 now this time has to be 3 squared, because what do I want on the bottom? So this on top ends up being 2 times 3 squared, but on the bottom I have 3 times 3 squared. Let's go ahead and multiply the top. That's 9 times 2, which is 18. But on the bottom, what do I have? 3 to the 1 and 3 to the 2, which is 3 to the 3. And see, those cancel. So what I have as an answer is the cube root of 18 all over 3. Okay, so now let's make it a little bit harder. Whoops, let's get that out of the way. Get that one out of the way. Okay, now this time let's make it fourth root of x over y squared. So what I'm going to pick for my number 1 has to be decided by whatever the denominator is. So here's what I have. Here's what I want. I want the bottom to look like this. I want it to look like y to the fourth rooted, so that I can cancel those. Well, that means underneath here, since I already have 2, I need another 2. So because this here let's do it in pink, this pink box has to be the number 1. So what I need is this item right here to be y squared. So let's see, multiplying on the top, I have x y squared, and then that does not simplify, so leave it as the fourth root xy squared, and on the bottom, remember, these canceled and I was left with just a y. Okay, so you can kind of think of it as the have, need, want process. I underlined those out of order. Okay, let's do one more. Okay, now this time what I'm going to put, let's see, I'll put a 2 on top. On the bottom, I'm going to put 9y, and I'll make this a cube root. Now, you could multiply that top and bottom by 9 squared y squared cube rooted, but that's not going to be sort of the cleverest way, because then you'll have to simplify a whole bunch. Instead, what you should notice is that 9 is already 3 squared. This is y to the 1. So instead of picking something that makes me have to simplify a lot. Remember, the pink box is 1. Let's pick something that will come out really nice. So cube root on top and bottom. I already have 3 to the 2, so now I'll make it 3 to the 1. And y to the 1 right there, so now I'm going to have y to the 2. So 3y squared underneath the radical. On the top, this 2 right here is in front of the radical, so don't multiply that with the 3 underneath. So I have 2 times the cube root of 3y squared. And then on bottom, what do I have? The cube root. This is now 3 cubed y cubed, but those are going to cancel. So then I have 2 times the cube root of 3y squared all over 3y. It doesn't even feel like we did anything helpful, but technically that's simplified. And the reason is that it doesn't have a radical in the denominator. So we say this is simplified. Okay. So the important thing to note here is every problem you have to ask yourself, what is the root? So if it's a cube root, you need to make everything to the 3rd power underneath there, like we did in this problem right here. And if it's a square root, then you need to make everything a power of 2. So 4th root, you need to make everything underneath there a power of 4. So the most important thing is, what is the root? If you can see what the root is, whoa, then that'll help you determine what you need to put in the box that we're calling the number 1 box. Okay, hopefully that helps.